Hey guys, this is Keanu again. This is video 2 of my physics lessons, physics calculation lessons. This video just explains some general math skills that we will need throughout the rest of the program that I'm hoping to do. So the first thing I'm going to talk about, scientific notation. I don't even know if you can read that. Scientific notation. Sorry, that's really bad. That is basically just taking really big numbers and putting them into a smaller, more manageable form. So this whole thing is just going to be explaining and doing examples. I'll be doing a lot of examples, so just be prepared for that. So I'm going to start off with something really easy. So this is, well, I'm actually going to go, I don't know, I learned it the other way. I learned it scientific notation into standard, but I'm actually going to do standard into scientific notation because I think that works better. So if I do 16, just easy, simple number, yeah, that's very easy and simple on its own. And so this, with all of scientific notation, I'm going to teach you later on in the video, will be very important throughout the rest of everything. So 16 itself is a very simple, easy number, but you can use scientific notation, which can actually make it harder, but we'll get to examples that work better. So 16 in scientific notation. So this thing for scientific notation is something point something times 10 to the something. You're going to have a bunch of different numbers that can work in this, and you can also have negative exponents here. The important thing to remember is this something point something is always going to be in the range of 9.9 repeating to 0.0 repeating then 1 at the end. It's like if you have a bunch of zeros, so it's like 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, on and on, and then you end up hitting 1 at the end. That is your range. You will never, you are not allowed to have a 10 as scientific notation. You can also cannot have 0 in scientific notation. I'll explain this in a little bit. So when you do 16, what you then do is you then go, okay, 16, it's in the tens. We're not allowed to have more than 10. So, which means we then go 1.6 times 10 to the 1. So times 10 to the 1, that's just multiplying by 10. If you go 1.6 times 10, you get 16. Easy, simple as that. That's not a hard example. Okay, let's do something bigger. Let's do 8,000 equals, okay, what do you think? Well, my thought would be, if I have 78, I can do 7.8 times 10 to the 1, 2, 3, 4. 10 to the 4 is 10,000. 10,000 times 7.8 is 78,000. Nice and simple and easy. Let's go the other way. 0.0043. That, okay, so you can go, okay, well I have a 4 and a 3. Let's go 4.3 times 10 to the, since it's a decimal number, it's getting really small. What you then have to do is this is actually going to be a negative exponent. So you're going to get a 1, 2, 3. So negative 3. Because this is actually 4.3 times 1 over 10 cubed. So 1 over 1,000. Which also as well is 4.3 over 1,000. Which is that number. So you're going to get that number. So you can see those things. What you always want to do is take your decimal place and move it up between numbers that will make sure this is between 0 and 10. You always got to make sure that this is between 0 and 10. So you just move your decimal place. However many times you move your decimal place, that is how many 4s you're going to, or that's how many 10s you're going to have. This you have 1, 2, 3, 3. This you have 1, 1, 1, 1, 2, 3, 4. Like I said before, 4. It's nice. It's simple. Imagine if you had 9,756,000,000 0. We'll just go with that, just because I don't really want to come up with any more numbers. That you can then go, okay, so I can't put here because then I would have a 97.56. I can't put here, I'll have 975.6. Can't put here, I'll have a 9,000, blah, blah, blah. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you know you're going to have 9. So you're going to have equals 9.756 times 10 to the 9. Nice and simple, 9.756. I will expand on this later on. Hopefully I'm actually still within my boundaries. Oh man, just fun. Okay. So, there you go. Nice and simple. That is the start of scientific notation. Putting normal numbers into scientific notation. Now to go the other way, it's not hard. Okay, so let's go 5.2 times 10 cubed times 3. So then goes, okay, so if you go 10 cubed, well, also going backwards, you know you can go 5.2, so I can just go 0, 0, 0, 0, 0, however many zeros. And I can just go, okay, well there's 3, so 1, 2, 3. So which then means I know I have 5,200, or 5,200, same thing. That is how you do that. Also, on your calculator, if I can find mine somewhere, what did I do with mine? Calculator, Mr. Calculator, oh, I'll have my answer sheet right on top of it. On your calculator, you will also find a little button that I'm not finding at the moment. It's a little EE button. It's going to be 2 E's right beside each other. Or it'll be like, God, how did I find this? I just got this calculator a couple months ago. I haven't had to do EE on this. Anyways, you're on your calculator, you're going to have something that's like E on it. Putting that in means you're then putting in scientific notation. So when you if you were to put this into your calculator, you would put 5.2 E to the 3, and that should get you this number. Should get you that number. If you have a good calculator. That is one thing I do need to say. If you have a good calculator, that is what a good calculator should have that. If you have something basic like a normal calculator, you won't have that. It has to be some form of scientific calculator. I had to get this one for my calculus class because we're not allowed scientific graphing calculators. So for math 1023, so grade 10, 11, 12, you're supposed to have a graphing scientific calculator, which has a really big screen and you can graph stuff. For calculus, I'm only allowed this because I'm not allowed to graph stuff. Because part of the lesson, which I'll explain later in other videos, I will have another series of videos going on that will be math related, just my high school math, is to have this, which is physics. Anyways, going back to that, this is basically times 10 to the blank. So whatever number you put in after this will be that blank. Okay. So I'm just going to erase all that. I'll give you another example. Oh, and of course, if you know 3, you know you're going backwards, which is something I'll just bring up right now. So 9.65 times 10 to the negative 4. Then equals, okay, so if I have 9 point, since it's negative, you know it's going to be going forwards. So I can have 0, 0, 0, 0, 0, 0, 0, 9, 6, 5. Okay, since it's negative 4, you know you're going 4 forwards. 1, 2, 3, 4. After a while, you end up just getting a hang of this and start going, oh, okay, how do I, like, I know I can just start doing this in my head. So which means you now get just this. 0.000965. There you go. Nice, simple, very quick, very easy, not hard to do. Now I'm actually sorry, just got totally distracted by my learning plan. So next thing I'm gonna do is significant digits. So this is going to be very, very extremely important in physics, chemistry, I think biology. I hate biology personally. I cannot do biology, but I have a very bad memory for all of that stuff. But that's just how I work. Okay, significant digits. This basically just says you have this many in a question, this is how many you're allowed in an answer. That's where this comes down to. If you have a number with 3 significant, well, actually I'll explain to you what they are first. So significant digits say how many important numbers there are in some number. So one of the first ones I have is 5.40. To yourself, take this moment, just say how many you would think. Sorry, that was real bad. Anyways, back to it. This would have 3. Some people might say that this should be 2, but this is actually 3, because this is the number that they give you. That 0 may not seem important, but sometimes that 0 will be extremely important. Because sometimes you're going to get numbers that are very ugly and repeating and stuff like that, that will end up that you'll need that extra space. There are also certain examples where that 0 will not be important. If you have another example, 0.0102. Okay, how many would that have? That actually only has 3 significant digits as well. Because this and this are only placeholders. These 3 numbers are the only actual important numbers in this whole thing. These are just placeholders because they have to be there. So I'll keep doing some more. 101.01000. How many do you think that'll have? That has 8. It sounds really stupid and really retarded, but that is actually true, because you have these 3 which are obvious. You have these 2 which are also kind of obvious, or at least this 1. So that's automatically 4. But since what it gives you is this whole entire number, you have to take them all into account. So it has 8. As always, with any of this stuff, leave comments. Leave multiple comments if you need to. If you leave one halfway through the video, and then you need another one near the end, cool with me. So, and here's something that you'll combine these two. If you get 1.2 times 10 to the 3, how many would that have? That would only have 2. Because you may think about it and say, okay, well 1.2 times 10 to the 3 is actually 1200, which would then have 4. That's actually what I got. This is my sheet that I'm getting all of these off of. And down here, I actually put 1200, and so I put 4. That's wrong. My teacher told me it's wrong. I got slapped in the face. Actually, I did. That's not true. But I got a mark off because I got it wrong. Anyways. Which I didn't get a mark off. It's just, there's like, yeah, no, that's wrong. I was like, oh, okay. So I learned. That is only 2 because there are only 2 there. That's what they give you. That's what they want. If you have something that would have 1.2, actually, this will be something that will come up next. So I'm doing another one. It's 9.010 times 10 to the negative 6. How many does that have? 4. Simple. 1, 2, 3, 4. Obviously, these are going to be really, really, really easy to count. That's also one of the reasons we use the scientific notation, because it makes things so much easier on us. When there's really, really huge numbers, really, really small numbers, it's definitely to write out 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. 0, 0, 0, 0, 0, 0. It's like a Google. That would be a pain in the ass. So that's why I got scientific notation. And I would love to know the scientific notation of that number. That'd be like 1.0 times 10 to the what the hell is going on. Anyways. So yeah, that's those. Next is just doing examples of actual calculations. So, one of the important things to do about significant digits is that when you're doing a calculation, your calculation, or your significant digits for your calculation, will always change depending what you're using it for. If you're using it for adding, subtracting, so like the one I'm going to do right now, you will always go to the least amount of digits after the decimal. So I'm going to do this. So you have x equals 4.30 centimeters minus 2.1 centimeters plus 94.999 centimeters. That, okay, so you just do it right off the bat. 2 or 4 minus 2 is 2 plus 9. Oh god. Oh no, that's right. Sorry. 96. So that's 96. 3 minus 1 is 2. Plus 9 is adding a 1. Sorry. I'm just doing this in my head, whatever. You get 97.199 centimeters. That is not your final answer though, because they have to take into consideration significant digits. Since we are adding and subtracting, we have to take into consideration least amount of digits after the decimal. Here you have 1, 2. Here you have 1, here you have 3. The least amount, 1. So you go 97.2 centimeters. That is your final answer. Quick, easy, simple. Just do as you normally would, then take that kind of thing into consideration after the fact. Okay, let's do another one. X equals 20.3 meters divided by 2.1 seconds. In this, so it doesn't matter about units, because when we continue on in this physics, you're going to continue getting different units and stuff like that. Units don't matter, it's the numbers that matter. Since we're dividing, then what we're going to be doing is we're going to be going by the least amount of digits total. Because as you can see, this has the same amount of digits after, significant digits after the number. They both have 1. So we just do our number. So 20.3 divided by 2.1 is 9.6 repeating meters per second. Then since we can only have the least amount, well, there's 2 here. Which means I can basically just leave it like this, except round it to 9.7 meters per second. That, most people should know, that is a repeating sign. So 9.6 repeating. That means this 6, it just goes on forever. Rounding it, since it's all 6s, it rounds up to 7. Okay. Like I said, pretty easy. Pretty easy. Like I said, always leave comments if you're confused, if you need something. Yeah. So do x equals 0.024 meters squared over 0.1 meter. This is something that will become very, very important in math and physics, is this unit. And as well, it's a variable. So when you have meters squared over meters, that means there's meters times meters. So 0.25 meters times meters over meters. Well, if you have meters and meters over meters, you get 1 that cancels. There you go, nice and simple, and you just do your calculation. 0.024 divided by 0.1, 0.24, 0.24 meters. Obviously, we're going to have, since it's dividing, least number of significant digits total, so we're just going to have 0.2 meters. There we go. Nice and simple. Here, I'm just going to do one more that goes back to the adding and subtracting, and then we'll be done. X equals actually, this is what I should do. 2.3 centimeters minus 1.15 centimeters divided by 3.3. 3.3 centimeters. So in this, we obviously have subtraction and division. So in this, what we have to do is least number of significant digits total. The division takes priority over the subtraction. So just do our calculation. 2.3 minus 1.15. Always remember, do what's in the brackets first. Brackets are more important, unless you have exponents. Exponents are more important than that. Then you divide that by 3.3. You get 0.348 repeating. So which means there's 348, 48, 48, 48, 48, 48, 48, 48. That 48 repeats on to infinity. We then have to go least number of significant digits total. Yeah. Which means I can then go 0.35. This 8, obviously it's 4, 8. So this 8 will round this 4 up to a 5. There we go. Oh, and this is nothing. Nothing. Because you actually get, since this is subtracting, it's not going to do anything to the units. Units are the same. Then you have centimeters divided by centimeters, which means you're just left with nothing. So there we go. 0.35 is your final answer. Anyways, always comment about what you guys want to hear, want to see, want to talk about. Keep watching my other videos too. I'll be hopefully putting some of these up every couple of days. So yeah, like and subscribe. Keep the views coming, and hope you guys like it. Hope you guys learned something new too. Bye for now.